Chapter 11, Chapter 12, scratch that. Chapter 12, Lesson 8, writing equations. If you recall yesterday, given a graph, first of all, we graphed it with a t-chart and found some y values that worked. But then I said, can we do this without using a t-chart, simply using the starting value and the slope? Well, if we start with an equation and create a graph, today our goal is heading in the other direction. Starting with the graph, let's write an equation. Oh, that would be a positive too, Mr. Callan. Starting at $2, going down $3 a day, $3 a day. So that's our goal for today. I will write a linear equation when given its graph. We had some notes from the previous day. So just to remind you, just to take you back on a little walk down memory lane, noting that our starting value, if x was 0, y is equal to 3, we could place that first point. And then our slope tells us that we could first go down 3 and right 2. Or we could also go up 3 and left 2. And those solutions are not the only solutions. In fact, there's so many solutions, it's not even funny. So we represent the number of solutions on a graph by drawing a line. Same thing here, starting value of -1. Slope in this case was +2 to +5, so we go up 2 and right 5. But we could similarly go down and left and still have a positive slope. Now we represent all the billions and billions and infinitely many solutions by drawing a line through those points. Hey, what about that last one? Mr. Callan, it starts at the origin. And if you need a rise and a run, you could simply put a 1 in there. So we can go down 4 and right 1. In a similar way, we could go up 4 and left 1 and still have a nice negative slope. So that was yesterday's notes. And so go ahead if you need, whatever the assignment number, whatever the date, pause, take a look at these answers. Come on back when you're ready. Pay special attention to the red y-intercept, and the green dots will show you how to use the slope. Take a look at these top ones. I'm going to zoom in a little bit. Pause and come back when you're ready. Often questions asked, number 22. If you don't see any x's, then write that you have 0 x's. And put a 1 under that. Rise of 0, run of 1, rise of 0, run of 1, rise of 0, run of 1. Or go down 0 and left 1. Of course, that's going to still give you a horizontal line. Problems like 23, 24, don't forget, if you'd like to write a 1, that would make your life a lot easier. And seeing that both of those are integer slopes, but notice the biggest difference, 24 is a -1 to 1, 23 is a +1 to 1. Now, I'm going to hold off on the bottom because that's where we're heading today, how to write equations. Whatever the date, whatever the assignment number, pause, get ready for some notes. Come on back when you're ready. I do have notes, ladies and gents, online on Kami. If you are unable to join us in class, you're welcome to open up that file. But let's go into it. This should look familiar. We call this a y equals mx plus b equation. It's actually called a slope-intercept equation because the coefficient in front of the x is the slope or constant rate of change. The constant term without a variable at the end is the y-intercept, which we can also call the starting point. Three most important ideas to writing equations. First, find that starting point. That's the b term, that's the number that's on the end. And just make sure to ask yourself, does it start in the positives or does it start in the negatives? Then find the slope. That would be the m coefficient in front of the x, in front of the variable term. Again, ask yourself, is it positive or negative? Lastly, ensure that your formatting is correct. Make sure you got a y equals. Don't forget that equal sign. Make sure you have an x in there as well. Now, mistakes, perhaps you won't be surprised. Most common mistakes are knowing differences between positive and negative slopes. Furthermore, make sure that your starting value starts on the y-axis, not the x-axis. That's why we call it the y-intercept. If you have a question at this point, I want you to write down a question. What question do you still have about writing equations? Pause the video if you need, write that question down, and bring that to class or send me an email. You know I love questions. Now, as an example, We're going to write an equation for this online shopping. I notice that it is the cost that depends on the pair of slippers. Because cost is the dependent variable, I'm going to go ahead and write cost equals. Now, what does it start at? How can it be $5 before you buy any slippers, Mr. Callan? Well, don't think of it like before. Think of it like, what's the constant? Oh, maybe it's a shipping fee. Look, they're going to charge you $5 for a box, and now tell me how many pairs of slippers that you need. Now, going for the slope, this doesn't increase 2, ladies and gents. Don't just count tick marks. If you look at the scale, it goes up $5, $10 for every 1 pair. So I'm going to go ahead and write plus $10 per pair. And yes, you can flip that around if you'd prefer to write the constant rate of change in front of the starting value. We're actually going to emphasize writing it in y equals mx plus b form, where y is the dependent or vertical variable, and x is the independent or pair of slippers. Student with strong skills can write 1. Student with the strongest skills can write that in 2 or more ways. So always try to challenge yourself to write an equation in 2 or more ways. Now, what if it does not have a real-world situation? Remember the steps. First, find that y-intercept. So if I go down there, boom, right where it intercepts the y-axis. In fact, why don't I bounce over to the other problem as well? Some people I say, look, put a marble on the line and let it roll down until it hits the y-axis. Not there. That is the x-axis. Keep on going. Shaboom. There's the -4. Oh, we have a similarity. They both have 4, except the problem on the left is a positive, problem on the right is a negative. Now we're going to need to find another point in order to figure out what the slope is. What is the m coefficient? So I'm going to take a look on the left, and I'm going to start at the red, and I'm just going to go down and down and down until I find there's one. Yep. So our slope appears to be -3 to 1. Now some people might say, Mr. Callan, I don't like that point. I like this one better. Okay. What happens when you go down 6 and right 2? Or up 6 and left 2? Well, it's still going to be the same slope. You may write -3 to 1 if you wish, ladies and gents. I want to be clear about that. Most people prefer just to write y equals -3x plus 4, but you can write -3 to 1x plus 4. Now let's head over to the right example, and I'm going to just kind of start this up. And oh, wait a second. No, see that would go right, that would go up too, but how much does that go to the right? Is that 0.8? Is it 0.9? Is it 0.83427? We don't know. You have to be precise, folks. Even this one, again, close, but how much does that go up? It would be in the middle of something. It's not an integer. The point is, to be precise, let's find a really nice point. I'm going to keep going, as a matter of fact, there's only one other nice point. In this particular problem, we're going to increase 9 for every run of 4, and that neither divides nor reduces, so I'm just going to write 9 to 4x. Look at those problems. How are they similar? They both have y equals. They both have a number in front of an x. They both have a number behind the x. How are they different? Well, the one on the left starts at +4. The one on the right starts at -4 on the y-axis. Problem on the left has a negative slope. It's a negative integer slope. The problem on the right is a positive slope, and it's an improper fraction. Nevertheless, we need the slope and the y-intercept. That is the big similarity for both of these problems. Let's go ahead and do some homework problems now from yesterday's assignment, from the previous assignment. If you're ahead, you can fast forward the video. I'll do some from the other assignment as well. So, number 25. If we started that marble and we rolled it down, it would appear that the starting value is +3. Now you may choose any nice point. I see a nice point here. I see a nice point here. And whether you do 2 to 5 or 4 to 10, notice that those are similar triangles because they have proportional slopes. So I'm going to use the simplest form, 2 to 5, and there, ladies and gents, is our equation. Y is equal to -2 to 5x plus 3. Let's do another one on number 26. Roll that marble down, and what I'm seeing is that it starts at -2. Now, do you have to write plus and negative? No. Some of you might just choose to write subtract, and that's okay. Now let's be picky with our points. I see a good few points. Actually, I could even go down. But no matter what, it's always going to reduce to the same quantity, a rise of 3, a run of 2. 3 to 2 neither divides nor reduces, and of course it would be a positive. Let's do one more on number 27. Roll that marble down. If you need to, pause, write your equation, come on back and check yours. Positive 2. Let's find another point. Actually, there's several. Noticing that it goes down and to the right. Now, 1 to 2 neither divides nor reduces, but the opposite of a positive is a negative. You could write negative 1 to 2 if you wish. You could write 1 to negative 2 if you wish. Do not write negative 1 to negative 2. Lastly, what's missing in the equation? Ah, yes. Don't forget in your formatting that the slope should be a varying term. It goes down $1 every 2 days, but times how many days, right? So you don't forget the x. All right, pause your video. I want you to try 28, 29, 30. Come on back when you're ready to check. Be sure you're ready. And here we go. Number 28, y equals negative 3 to 5, x, subtract 2. 29, y equals 5 to 1, or yes, you may simply write 5 wholes, x minus 5. And number 30, y equals negative 3 to 1, x plus 1. Again, to emphasize, you may write simply y equals negative 3x plus 1. I like to see the rise and the run personally, but that's my preference. Now let's get into today's assignment and do some real world. We just worked a lot with these kind of problems. What about if it's a real world problem? It doesn't even have all four quadrants. Well, I'm not going to write y equals blank x plus, actually you could if you wanted, but I'm just going to say, what are we measuring? We're measuring earnings or magazines? Well, earnings depends on the number of magazines sold. I notice that it starts at 0. In fact, this is a proportional relationship. No, you don't have to write the 0, but some of you will choose to, just to be clear. Now I'm going to find some nice points, and again, don't count tick marks. That does not go up $1, that goes up $5 for every 2 magazines. Now you can write $5 for every 2 magazines. Some people will choose to write $2.50 per magazine. And of course, now, if you want to, and I'll try to do this, change it to y equals mx plus b form. Any of these are good. If you'll forgive me for rushing through this without reading directions, you're asked to write an equation for each given real-world problem, but it also gives you a challenge to write the equation in as many ways as possible, 2 or 3. Don't go crazy and go 5 or 6. All right, let's go on to the next one. Again, what are we measuring? We're measuring cans. Cans is dependent on the number of days. In fact, I'm going to start with 34. And note that the number of cans goes down, but how much does it go down? It's hard to tell just by looking at the boxes. But folks, when you can't tell by the boxes, look at the numbers that they give you. It goes down 3 cans for every 1 day, and down another 3 cans for every 1 day, and down another. Okay, we get it, Mr. Cowan. So I'm going to write down 3 cans per day. Yes, you may write the 1 underneath of it if you wish. If you're looking to put it in y equals mx plus b form, we're going to put the negative 3 per day first. And since that's a positive, we'll write a positive 34 next. Pause the video. Try number 3. Come on back when you're ready. Depth equals, Mr. Callan, what is this? Is it 2? Is it 3? Is it 4? Is it 3.5? That's going to be hard to tell. So in this case, I can't actually identify the starting value. I do see that the depth increases, the depth of the hole, and it increases by the same constant rate of change. Hard to tell by the graph, so let's look at the numbers. In fact, folks, you could even turn this into a table. 1, 18, 2, 33, 3, 48, 4, 63, and so on. Now I notice in doing that it increases 15 feet every hour. So I'm going to write 15 times h hours. Okay, now go backwards, get rid of that 15 feet that was dug, and you'll find that it starts, for those of you that guessed 3, you were correct. Let's write it in y equals mx plus b form, where you could write the 15 per hour first and the positive 3 second. All right, so now you have it. You know how to do real world equations. You know how to do y equals mx plus b equations. Go ahead and continue on with this assignment. Bring some questions if you got any class. Do well, folks. Let's grow.